Hi, everybody. I'm Alex Thornton, Executive Director with LF Energy. Thank you so much for having me today at the Open Source for E-Mobility Summit. I wish I could be there with you, but we'll have to settle for this recording. So originally I was going to talk about how open source can drive innovation in EV charging and energy. And then I looked at the conference agenda and saw that I'm the last one sitting between you and probably some beers and networking. So I decided to mix it up a little bit. And I'm going to talk instead about why it's an amazing time to be working on e-mobility and open source, why you're in exactly where you should be in the most interesting time to do it. So let's get to it. First, I'm going to start with some really bad news. It is hot. Last year was the hottest year on record, 1.48 degrees above pre-industrial averages. And the trends aren't looking very good. As you can see, temperature keeps going up and up. And quick plug, a lot of the slides that I have today were pulled from this guy, Nathaniel Bullard. If you're looking for a crash course in decarbonization, check out that link. So it's hot, it's getting hotter. And the reason it's getting hotter is, as we know, greenhouse gas emissions. Of all greenhouse gas emissions, roughly 3/4 are coming from the energy sector, combustion of fossil fuels. And a little over a fifth, or a little under a fifth, are coming from transportation, for mobility. And so there's a lot of impact that we can have if we decarbonize the transportation sector. But if we stick with energy overall for now, so we have this big problem, world's getting hotter, greenhouse gases are causing it, we need to decarbonize energy. How do we do that? What is the recipe to decarbonize energy? It's pretty simple, actually. Step one, you convert energy consumption to electricity. So things like cars that were previously burning gasoline or diesel, you get them to run on electricity. You do that with everything. And then once everything's running on electricity, you make sure that your electricity is being generated by carbon-free sources. So instead of producing electricity with coal or natural gas, you produce it with solar or wind. And this is what we call the energy transition. This is happening worldwide. It's happening faster than we expected it, which is a good thing. And it's fundamentally changing our lives and how we interact with energy consumption and production. There are a number of implications that go with this energy transition. The first, variable renewable generation is increasing. We have this massive increase in generation from things that we can't control when the sun is shining or when the wind is blowing. And if we look, solar and wind are the fastest sources of energy that we've seen, maybe ever, but at least in decades. And you look, that curve is extremely steep. And so this is only going to increase. As of now, wind and solar generated 12% of global electricity. And new capacity, new generation capacity is going to be solar and wind as well. And so that number is just going to keep going up and up. And this is happening because those are actually the cheapest sources of electricity. The cost of solar has plummeted by 99% since 1975. This is a miracle of R&D. It's happened far faster than anybody predicted and is revolutionizing how we produce electricity, and has serious implications actually for electric vehicles and e-mobility. All right, so now electric load is increasing. We're converting those cars to EVs. We have data centers. We are producing green hydrogen that's fed with electricity. So if we talk about cars for a little bit, EV market is growing dramatically year over year. So it grew 34% in 2023. And that number keeps going up and up and up. And this is happening across all sorts of, areas that were previously fossil fuel consumed. So heat pumps are becoming more popular than natural gas furnaces, for example. Now, previously, when we had large centralized power plants and single directional consumption, we're now switching to what's called a bidirectional system. And so on the left, we have the historical power grid, very large central power plants feeding one way to where that electricity is consumed. And now we have many small power producers spread all around. You might even have solar panels on your roof. Your electric vehicle might be charging, or discharging within your own house. And that has fundamental implications for the physical infrastructure and the physical grid. You also have batteries being deployed in massive numbers because, again, you can't control when the sun is shining or the wind is blowing, and so you need some sort of storage mechanism to help even out the peaks and valleys. And all of these are distributed energy resources, not these large centralized power plants that we had previously. And last, we have what's called grid congestion of now you have all of these changes happening to the physical infrastructure of the power grid. You're trying to shove more electrons through it than before, and sometimes you get a traffic jam. And this has monetary impacts in the US, $20 billion caused by grid congestion. Um, in Europe and Germany, we have, there are energy impacts as well in terms of like how you need to manage this congestion of finding power from different sources or rerouting it in less efficient ways. And so we're at this stage where you have this physical infrastructure of the traditional power grid that's being strained by all of these changes that are taking place. And the way I look at it, this is a digital orchestration problem. How can we optimize and orchestrate the physical assets that make part of our electric grid so that we can actually meet the challenges of the energy transition? And so what's emerged is this concept of the smart grid, of overlaying a digital layer on top of the physical. And so we have the generation, transmission, distribution, residential, commercial, industrial, and it's becoming more and more like a telecom network, IoT system, where everything is communicating with one another and everything is controllable. And the smarter that we can get with orchestrating all these various aspects, the more efficiently we'll be able to deploy capital, and the more efficiently we'll be able to use our physical resources to actually manage the energy transition. And e-mobility has a very, very critical role to play in all of that because it's a massive consumer of electricity and it's a portable battery. It can charge and discharge. So where we are now, it's getting hot. We need to decarbonize, and therefore we're going through the energy transition. Now there's good news. We're starting to wisen up that we have to make this transition, and there are trillions of dollars that are flowing towards it. Last year, $1.8 trillion going to the energy transition. This is across renewable energy, transport, power grids, and other. If you're a startup looking for VC funding in Europe, climate tech is the biggest area of VC funding in Europe right now. It's a very attractive sector for investors, for startups, for entrepreneurs. It's growing very rapidly. In EVs, collective investment has surpassed $1 trillion worldwide. So EVs are very much the future. This is how we're going to get around 10, 20, 30 years from now. And it's only going to accelerate because of this significant investment. Because of all this investment, we're seeing fundamental leap forwards in technology. So battery prices are falling significantly, similar to what we saw with that PV pricing cost curve. We're seeing similar results with batteries. The cost is going down year over year. And likewise, the density of batteries is going up year over year. And what's beautiful about this is it makes EVs more and more attractive as prices fall and energy density increases. And because of all these improvements in batteries, uh, EVs now represent 18% of global car sales. And again, that number is only going to keep going up. And so this, for folks who are working on e-mobility, you have a huge market that is only going to increase. A wonderful place to be. So now, hopefully you're convinced that this is a great time to be working on e-mobility. You get to participate and contribute to once-in-a-lifetime shifts in mobility technology. You get to have a massive positive impact to decarbonize our society. There's a tidal wave of investment and growth, which results in business opportunities. And this is just getting started. This is going to go on for decades to come. All right, so you're sold on mobility. Why open source? So let's start with some big numbers. There's a report that came out of Harvard last month, and they tried to research the value of widely used open source software. And they started by talking about what's called the supply side value of if you took all this the widely used open source software and you had to recreate it one time, how much would it cost you? And they put that number at $4.15 billion. Not small, but also not huge. Google could do that in a year if they wanted to. Now, the power of open source is not creating it once, but the fact that it's this foundational layer that can get used again and again and again and again, right? It's that reuse. That's where the real power is, and that's where a community can build up around it. And so then these researchers looked at the demand side value, and that's the eye-popping number, $8.8 trillion. So this is the cost where if every consumer of this widely used open source software had to build it themselves, and then you summed all of those repetitive efforts up, you would get to this $8.8 trillion. So imagine a world where everybody was using or building their own proprietary closed source software. You would get to a number kind of like this. And now you start to understand that closed source is not, it's just not viable. It doesn't scale. It's not high leverage enough. Open source gives you higher return on investment. And so especially for folks in policy and in climate tech that are guiding a lot of this $1.8 trillion for the energy transition, they realize that and they're looking for high leverage solutions. They want to invest in the areas that are going to give them the highest ROI. Now, the other part is more and more closed source doesn't have a moat. AI is a great example, the most cutting edge technology that we have in the world today. There was a memo leaked from Google sometime last year where somebody said they don't have a moat and OpenAI doesn't because open source is coming to eat their bacon. And then an investment firm put out a chart that showed the improvement trajectory of open source AI versus that of private AI and how open source is catching up rapidly. Open source is going to come to dominate AI, just as it's come to dominate many other sectors. And the reason being, with a community, the pace of innovation is so much faster than closed source. Closed source doesn't stand a chance. I'm sure you've seen this maybe today about all the different standards and protocols that EVs need to deal with to charge. And so, I think you probably by now understand how open source ensures interoperability and maintainability. I want to take a slightly different angle on that and talk about smart heat pump water heaters, which are one of my favorite devices because it's not obvious, but a water heater is actually a type of battery. You heat up water and then it's well insulated and that water stays hot and you can use it later. You don't have to heat it up exactly when you're using it. And so in the case of electric heat pump water heaters, this becomes a great asset where if properly orchestrated, you can heat up a fleet of water heaters when there are carbon-free sources available. and then you can consume that hot water later on, and you don't have to use electricity when it's a dirtier mix. And there was a case in Canada where uh, residents were offered rebates to install hot water heaters with the understanding that they would participate in a program to orchestrate and coordinate these hot water heaters to become grid assets. And unfortunately, the manufacturer of a component of the water heater went out of business. And because they were using closed source proprietary code, those water heaters are now stranded assets. It's not actually possible to do what the rebate was intended to do and coordinate them as grid assets. And so this is an area where open source, if you're a policymaker, it's a clear winner. And last, open source is good business. The most valuable, profitable companies in the entire world, Microsoft and Google, are also the biggest open source contributors. There's a clear correlation between how they contribute to open source and how they're able to leverage it to drive profit and revenue. Okay, so given all that, e-mobility is great. Open source is the way to do it. Where does the Linux Foundation come in? Well, one of the concerns sometimes with open source is that you have all of these mission critical systems, services, digital infrastructure dependent upon open source projects. And sometimes you worry that the open source project is just maintained by one person who's unpaid. It's a massive risk, and it's not fair to that one person. And so this is a situation that the Linux Foundation exists to avoid. Instead of having this, we like to build large, thriving, sustainable communities. And the way we do that is we think about open source projects that lead to commercial products that generate profits for a company. And then those profits are reinvested back into the open source project, and it goes around in a virtuous cycle. You can see an example of this with Linux. Linux, probably the most well-known, impactful open source project in the world. There's Red Hat. They have their commercial enterprise Linux offering on top of that. They generate profits, and then they contribute upstream to the Linux kernel. In the case of Pionix, they have the Everest project, and that feeds into their commercial Basecamp enterprise grade offering. That generates profits, and then they're able to feed that back in to the open source Everest project. So open source and commercial viability go hand in hand. The success of the project is contingent on the success of the maintaining companies. Now, the Linux Foundation focuses on basically everything except code. So there's a wide array of services and support that we offer these project and communities, including neutral governance, handling IP, events, meetups, training, certification. I'm not going to go through all of it, but basically we try to do whatever we can in terms of non-code contributions to make sure that we have that thriving, sustainable community. LF Energy, we have a number of members, and it's important to note we're a nonprofit organization that's funded by our members. And we also have a number of projects, some of which are Citrine and Everest in the EV space. We're looking for a lot more EV projects. It's a great area of opportunity, so we encourage you to come join us. Now, why would somebody want to become a member of the Linux Foundation or have their project come? Well, it's important to note, as a nonprofit, no one is obligated to give us money for any reason, right? It's open source. It's free to use, free to contribute to. Anybody can join these technical committee meetings. And so the reason somebody would come to us is because we help them to be successful. That's our job, to do whatever we can to help these projects and companies be successful. And if we can do that, then we get more members and more projects. And the way we go about doing this is we have three core company values: helpful, humble, and hopeful. So, helpful, our job is to be support. Anything that we can do to help the success of the project and community, that's where we need to pitch in. Humble is recognizing that we're not the ones doing the core of the work here. We're supporting cast. And so making sure that we understand our place and we elevate the projects in our communities and stand in the background is essential to our success. And then last, hopeful is, we need a certain amount of naive optimism to think that open source can change the world. And indeed, over the past, 20 or 30 years, it has. And we expect that trend to continue. And this hope is what drives us to continue expanding open source's influence every single day. For those who don't know, there's an American TV show, Ted Lasso. Goofy American football coach goes to England to coach soccer, takes a ragtag bunch of players and convinces them to work together to achieve amazing things. And that's really what I'm inspiring you to do today. We have a tremendous problem on our hands, but we have a pathway to solve it. And you're working on the most impactful, interesting area with amazing business opportunities. And you have the tool of open source to go ahead and attack it. So go connect with each other, believe in each other, and we're going to do amazing things. Thank you very much for your time. Have a great rest of your event.